Okay. So welcome to this physics live class. So in this live class, we are going to look at the two examples of a series and a parallel circuit. So this is how questions will come in your 2026 GCE paper. So you have to make sure you follow and pay particular attention. Yeah. So this is a continuation of my part 2 video where I ended on the circuit diagram. So this video will help you to solve questions in paper 1 and section B. So pay particular attention. So we'll start by solving what? The first example, which is an example of a series circuit. So we have this diagram, we have a battery here which represents what? 12 volts, and we have two resistors which are connected in what? In series. So how do you know that these resistors are connected in series? So we say that series, it is connected in what? In chains. So these are chains. There is no other pathway. Then we also said, we also talked about the voltmeter. So we say that the voltmeter is always connected in what? Parallel. How do you know that something is connected in parallel? Because of the junction. So we have the junction here, which represents what? The parallel. So now, to begin, the diagram is saying calculate the total resistance. So if you remember, I gave you the formula for total resistance, which you are going to be using in what? In series. So in other terms, they might not ask you to calculate the total resistance, but they may say calculate the effective resistance. So don't get confused. The effective resistance and the total resistance is one and the same thing. So how do you calculate it? So you say then total resistance is equals to resistant 1 plus resistant 2. So if we go back to our diagram, we can see that our resistant 1 is what? 2 ohms. So you say 2 ohms plus our resistant 2 is what? 4 ohms. So you say 4 ohms. Then if you add 2 plus 4, you get what? 6 ohms as your total resistance. So this is how simple you can solve the total resistance in case you have what? A series diagram. So don't forget to subscribe to my channel so that you don't miss out a full revision where I revise the top repeated questions on current electricity. I'll post the video on my channel. If you want the link to the entire video of the top 7 questions which they bring always on electricity, feel free to inbox me so that I can give you the link to the video. So continuing with our question. So part B is saying calculate the current through the cell. So remember what we said? We said that current in a series circuit is always what? The same. So meaning the current passing through the 4 resistor and the current passing through the 2 resistor are one and the same. So how do we calculate now the current? So remember I told you the formula which you need to remember for current is current is equals to voltage divided by what? The resistance. So remember, for us to calculate the current, we have to use the total resistance, which we calculated on the first part. So if you make a mistake in calculating your resistance on the first part, meaning your second question will also be wrong. So we are saying that the formula we use for us to calculate the total current through the cell is current is equals to voltage divided by the resistance. So this is the what? The total resistance, and this is also the total voltage, which is the voltage of the battery. So now, what is the voltage of the battery? So the voltage of the battery we have is 12 volts. Then what is our total resistance? So our total resistance is what? 6 amps. Then this gives our current to be what? 2 amps. So that is how simple questions on electricity are, if you just understand the concept. So I've made videos, part 1 and part 2, where I've explained all these formulas you are seeing here in a simple way. So if you want the video, feel free to inbox so that you can get the link. So moving on to our final question, which is part C. So part C is asking us to calculate the potential difference of each resistor. So here we are calculating now the potential difference of each resistance. So how can you calculate the potential difference of each resistance? So remember, we said that in series, the voltage is different. So meaning has a different voltage. So that's why 1 and voltage 2. So now calculate the voltage. So remember, we have the formula for current. So we are saying current is equals to voltage times resistance. So remember, we said that the current in a series is the same. So meaning the current we use at the first resistance and the current we use at the second resistance will be the same. So you say now, what is our current? Our current is 2. What is our potential difference at the first resistance, which is 2 ohms? So you say voltage over 2 ohms. Then here you do what? You cross multiply. So our V is 4 volts. So meaning at our first resistance, our potential difference was what? Was 4 volts. So that is the first thing which you need to do. So now, since we said that the voltage is different, so now you proceed to move it to your second resistance. So this is at what? The 2 ohm resistor. Now the second part we are calculating now for the what? For the 4 ohm resistance, because we are saying the potential difference is different in series. So now you say again, current is equals to voltage over the resistance. So what is our current? Our current is the same. So you say 2. What is our voltage? We are calculating the voltage, V. What is our resistance? So the resistance, we say it is what? 4. So here again you cross multiply and you find that your voltage is 8 volts. So meaning your second voltage is 8 volts and your first voltage is what? 4 volts. This proves that our voltage is different in what? In series. Then if you add voltage 1 plus voltage 2, we said you are going to find the what? The EMF is your total voltage the battery has. 8 plus 4, we have what? 12, which is our total voltage the battery has, meaning you have solved your question and it is correct. So now moving on to our parallel. So moving on to parallel. So this question now is about parallel. So we have a diagram with us, which is saying this diagram, we have a battery which has a 12 volts. We have our first resistant, which has 2 ohms. We have our second resistant, which has 4 ohms. So the first question is saying, from the diagram above, calculate the what? The voltage 1, voltage 2. So the first question is requiring us to calculate the voltage 1 and voltage 2. So how can we calculate the voltage 1 and voltage 2? So remember what I said. In parallel, so in parallel, we said what? The voltage is the same. So meaning here was they were trying to confuse you by saying calculate the voltage 1 and voltage 2. So since the voltage in parallel is the same, so meaning our 1 is equal to voltage 2, which is the what? The total voltage, which is 12. So you say, which is equal to the what? The EMF, which is the total voltage, which is 12 volts. So meaning our voltage 1 and our voltage 2 is the same, which is what? 12 volts. Now, moving on to our second question. Calculate the current 1 and the current 2 and the total current. So we say that in parallel the current is different. So the voltage is the same, but the current is what? Different. So here the current is different. So meaning we have to calculate each current the way we are calculating the what? The voltage in the first question. So now you start. You start with what? The 2 ohm resistor. So we'll start with the 2 ohm resistor. So you say, what is the formula for current? So our first current is what? Equal to the voltage divided by the resistance. So what is our voltage? We say the voltage is the same. So the voltage is 12. What is our first resistance? So our first resistance is what? 2 ohms. So you say what? 2. Then 2 into 12, you find that your first current is what? 6 amps. So our first current which you have solved is 6 amps for the what? For the 2 ohm resistor. So now moving on to our second resistor, which is the 4 ohm resistor. So you say the second current is equals to voltage divided by resistor 2. So what is our resistor 2? So our voltage is the same, 12, our resistor 2 is 4. So gives us our current to be 3 amps. So meaning we have solved our what? Our 2 currents. Now what is the total current? So the total current, you just have to add the first current, which is current 1 plus current 2. So what is our first current? Our first current is 6 amps plus 3 amps, which gives us 9 amps all together. Yeah, so this is how you calculate current in parallel. So remember, current in parallel is different, but the voltage is what? Is the same. Then moving on to our final part, which is the total resistance. So how can you calculate the total resistance? So remember, the total resistance in parallel is different. So how do you calculate it? So you have to know this formula. 1 over the total resistant is equals to 1 over resistant 1 plus resistant 2. So this is the formula which you need to know if you are calculating the resistance for what? For a parallel circuit diagram. So now, how can you calculate it? So we are saying we have 1 over the total resistance, which gives us, what is our resistant 1? So our resistant 1, which we had, is what? 2 ohms. Plus, what is our resistant 2? We had this what? 4 ohms. Then, remember, when we are adding fraction, we find what? The common denominator. So you say, what is the common denominator between 2 and 4? So the common denominator between 2 and 4 is what? 4. Yeah. So now you will say, what is 2 into 4? So 2 into 4 is what? 2. 2 times 2 is 2. Then you say plus. What is 4 into 4? We have 1. 1 times 1, we have 1. So meaning our 1 over the total resistance is 3 over 4. But remember that this is not the final answer, because here it is a fraction. We are saying it's 1 over the total resistance. So here the trick which you can use in case you are running out of time is just flip. So what you do on this side, you will also do what on this side. So in case we flip, it will become the total resistance over 1, which is equal to 4 over 3, which is 1 into the total resistance. We have the total resistance. Then 3 into 4, we have 1.33 ohms as our total resistance. So this is how simple questions come on what? On circuit diagram. So we have what? A parallel and a circuit diagram. So now, what are some of the advantages before I go? Because they may ask you, what are some of the advantages which you come across on what? On series and parallel. So the first advantage of a series circuit is that all components receive the same current. So this is the first advantage which you need to remember. So in series, we say that the current is the same. So meaning all the what? The component receive the same current. Yeah, so that is the first thing, advantage which you need to remember on a series circuit. Then what is the disadvantage which you need to remember on what? On series. So the disadvantage is that since all components receive the same current, meaning if one bulb or if one component stops working, if one component is not working, the other component stops. So this is advantage of a series circuit, meaning if you have connected things in series circuit, you will encounter this disadvantage. If one component stops working, the rest will stop. Then what are the advantages and disadvantages of what? Of a parallel circuit. So the advantage is the opposite of a series circuit. So meaning here, not the all components do not receive what? The same current. So here you can say the advantage of series circuit is the disadvantage of what? Of parallel circuit. And the advantage of parallel circuit is a disadvantage, meaning if one component in parallel is blown out, since they receive different what current, meaning the other one will still what goes on. So this is where our live or my live class ends for physics, current, electricity. So don't forget to subscribe to my channel so that you don't miss out the full package of physics revision on current, electricity, the top 7 questions which always comes on current, electricity, circuit diagrams, and cost.